Now use rank-dependent utility to accommodate the last experimental measurements that we did, the probabilities. You may remember in this figure you were asked which PE1 makes you indifferent to other questions of that kind were asked to you. And again, I'm going to present an exercise to you to analyze it. Again, we use the utility scaling that we know we can do under rank-dependent utility. Expected utility was predicting PE1 equal to 1 over 4, but empirically we find deviations. Let's look at the deviation PE1 exceeding 1 over 4. Can rank-dependent utility accommodate this falsification of expected utility? You can work on it and then pause the video, come back, but you can also do it for PE2 and for PE3. They also exceed the expected utility predictions. So now you can pause the video, work on it, come back when you're done. Okay, I assume you came back. I show you a solution. Repeat the stimuli, repeat the utility scaling. Then under expected utility, we would say the expected utility of left and right hand side must be the same. Now we do rank-dependent utility. Rank-dependent utility of alpha 1 for sure is simply utility alpha 1. Rank-dependent utility of the right lottery, you have to bring in W. The outcome rank best is alpha 4, so its decision weight is simply the W value of the probability. Alpha 0 is ranked worse. Its decision weight is the remaining decision weight, and that is this here. So here the right-hand side is a rank-dependent utility of the right-hand lottery, and this equality results from rank-dependent utility. Well, we know already many things that we see here. We know utility alpha 1 is 1 over 4, utility alpha 4 is 1, utility alpha 0 is 0, so the right-hand side is simply W of PE1. So we conclude from this, W of PE1 is 1 over 4. That PE1 we have to find. And now we should accommodate P1 being bigger than 1 over 4. But you can easily imagine how we can get that done. That is a W pushing down a little. It's underweighting, it's pessimistic. In that case, the W value at probability 1 over 4 is too small. It's less than 1 over 4. So we have to take P1 bigger than 1 over 4 to get the W value 1 over 4. For instance, we can let W take the value 1 over 4 at probability P is 1 over 3. So that's easy to do. So this exercise, this accommodation, because it's very easy to find W functions of that kind, you can easily do it. Empirically, we also often find other deviation where P1 is smaller than 1 over 4. That same kind of story. W should be overweighting probabilities, and then we get P1 smaller than 1 over 4 gives W value 1 over 4. So that's easy to do also. Now, if you like, you can work a bit more yourself on P2 or P3 and pause the video and then come back. Okay, now I go on with PE2 and PE3. Here is the figure PE2, how we measured it. Expected utility wrote that, but rank dependent brings in the W's. I did it here. We know that utility of alpha 2 is 2 over 4, so we get the W of PE2 is in fact 2 over 4, as simply having W underweighting there, pushing down, is enough to give PE2 2 over 4. Very easy to do. PE3, all the same story, so let me just be very quick. Rank-dependent utility equality, we get the WP3 is 3 over 4, and then just letting it underweight probabilities there gives you P3 bigger than 3 over 4. So that was all easy to do. I do want to discuss this page a bit more, look a bit more, because a nice surprise is awaiting us. And I ask you pause the video, look a bit at this slide here, and see if you can discover something very valuable that's going on here. So what is very nice? I know that's a fake question, but still try, and after a little while, when you're done, you come back. Okay, now I continue. So I tell you what is a very nice thing here. That is, first, we have here WP1 is equal to 1 over 4. WP2 is 2 over 4 and 3 over 4. We have here exact measurements of the W function. So this means that we are in fact measuring the W function in this experiment. That is what we have been doing. So that's very nice. We measure the utility function, but we also measure the W function already in the experiment. We measure the whole rank-dependent utility functional in fact. And by the way, if you look at these figures, you can compare them with standard Gamble questions. They had the same format. We did it when we did expected utility. Then we assume the probability is known, and then we use it to derive utilities. Here we do a sort of dual thing. Here we assume the utility is already known, and then we can use these indifference to evaluate the probability weights. So useful indifference in many respects. Anyway, you cannot draw your W graph from these observations. You may remember with utility, we had 0, 1 was scaled. We knew where utility was 1 over 4, 2 over 4, 3 over 4. We could draw the graph. With W, we're in the same situation. So on the x-axis, you put whatever your P1, P2, and P3 values are. They are different for every one of you. But whatever your value is, at P1, you know the W value is 1 over 4, 2 over 4, 3 over 4. You can draw the graph of your W function from the experiment. The graph that I drew here is the most commonly found shape. So at P1, it's a bit overweight. It's a close call there. And of course, your graph will be quite more noisy, look different. And of course, the experiment was quick and dirty just for teaching purposes. If you want to do a good experiment, you do much more measurements and much more time you spend on it. But at least you saw in principle, we can measure the whole rank-dependent utility function this way. This method of measurement that I showed you was in fact Abdellaoui 2000 in management study paper that showed that this can be done. So that showed to everybody that rank dependent is quite tractable. Because the first authors writing on, also Twisk-Kahneman 92 wrote on it, they wrote, this must be difficult to measure. We have non-linear functionals and many unknowns. And you see now it can be done in a parameter-free way, in fact, and just exact measurement and introspectively and also in interactive sessions. Well, it can be done very easily. So we'll discuss it a bit more, but that will be in the next recording.